All right, here's another video for the Base-12 book club designed for people who are interested or who have bought my book or who are interested in buying it and wondering what the big deal is. So first of all, this is the book. It's for sale on Amazon. There were some problems getting it out there, but I think it's all settled. You should be able to buy it if you haven't already. And for everyone that has bought it, thank you. And I'm enjoying getting comments about it, any questions that you have. So people are asking me questions and making comments. And one of them was, can we speed up these videos a little bit? You know, I'm putting them out like one every 2 weeks because I'm trying to do so many other things as well. But I hear you and I agree, and that's why I'm gonna start making videos more quickly. I think it's time. Now that I've got this book done, the idea is to get the message out, or get the idea out, or share it with the world. I think this is important. So this video, I'm actually going to stop going through the book slowly and just say, why is it a big deal? What's, like, who cares, basically? Okay, base 12, you know, you can divide 12 better by 3 and 4. So what? You know, why is it important? And so at the end of the book, I get into the physics, and it really is the physics community that's going to benefit, which ultimately the world's going to benefit from base 12. A lot of people, or the idea of base 12 has been promoted in the past as a better system by mathematicians because they point out that because it's, you know, your unit 12 is divisible by 3 and 4, and that makes things simpler. It's not just, you know, 2 and 5. And the problem is that it's such a big effort to do that, and we have such an established system already. It seems like it's not that big of a deal. It seems to be that things are chugging along just fine, and so any sort of movement towards changing our money system or our measuring system just sort of falls flat because it's pretty good, really. Like, we've come a long way. You know, we've put people on the moon and everything. We've done a lot. We have technology just chugging along. A lot of things are happening. So do we really need this? And so I say physics will benefit because it's what's going to happen is we have a philosophy built on the math that we currently are using, based on base 10. So the math philosophy of pi, it comes from the result of our version of pi. It's a long number that goes on for infinity. It has no patterns, doesn't repeat, and so it has certain qualities, and that because pi is such a famous number, and it sort of permeates the mathematics, it creates kind of a feeling like, okay, that's the base of mathematical reality. There's kind of no pattern. It just sort of goes into infinity, and that sort of flavors our perception of what math is, and the world itself. You know, the universe is sort of chaotic. Things are moving around so fast when you go into the really small, and there's all these planets and stars, and it's going around, and it's just like, infinity seems just to taper off in all directions. And that's the base 10 version. Irrational numbers. We have this model of a like, you know, of a solid length, solid line, and then it just kind of goes on forever, but really small. And there's been no real effort to explore that. It seems like that's just the way it is. So what I've discovered in base 12 is that there is a pattern. There's patterns in there, and now the challenge is to, you know, really see them clearly. You know, if you have a row of numbers and they kind of line up in order, that's a pattern. But what do those numbers represent when you actually look at the circle, or the inside of a circle, the area, or the inside of a sphere, you know, the volume of a sphere? What's going on in there? What's happening? Is there a pattern other than just, I don't know, a lot of stuff or something? So calculus has attempted to, you know, sort of slice up the circle into smaller and smaller little triangles, and then you kind of put them together, and you convert the area of a circle into a rectangle, and that's great. That's a start. That's a type of pattern, you know, just that sort of pie shape, all those little triangles getting smaller and smaller. But I think in physics, the actual structure of atoms and what's inside them, protons, what's inside a proton, as you go smaller and smaller, there's a structure there. Something's holding all that energy together so that we build up into the world that we're in. And so this is where the Base-12 comes in, and it's the acknowledgement of the empty space that's within irrational numbers. So the conclusion that I've come to is that our universe is built when we measure things in our world, the lengths of things are irrational. And that sounds like it's sort of somehow doesn't make sense. The word irrational, it's not rational, it's not logical. That's one of the difficulties with math terms. A lot of them are sort of contradictory sounding. It's completely normal idea to have to accommodate the empty space that's within everything. And so this is what the geometry of the circle that I've discovered shows us. And this isn't this diagram for 360 degrees isn't an invention that I've created using Base-12 math, and I've sort of built this structure. I think it already exists. And so in a way that's the feeling that I have anyhow, that Base-12 already exists. It emerges from the relationships of all the different components that make up the universe. So we have gravity and the strong force and the weak force, the energy that's pulling things together and repelling things that again builds up so we have the world that we live in. So we're talking about all the forces, like the speed of light, that make up our universe, and that they all exist. Ultimately, it's quantized. This is the whole idea of quantum physics, is all those tiny little bits and pieces. And so this is one of the questions in math people ask about, is the term is discrete or continuous. So when you have a line like the x-axis, a continuous line means there's no spaces in between anything, and discrete means there's actual individual units with some space. So the challenge is, if you have some space, what's the relationship between the lengths of the line and the space between them? That's a ratio right there. And this ultimately is what pi is. Pi is the ratio between the solid things and the little bit of space around them, and it builds up. So you start with a dotted line, and then you get chunks. You could build those together, and it's not just a line, but again, it's area and volume that we're talking about. And that's all happening inside the very, very small to finally build up into the world that we live in. So this is why Base-12 is important, because the ratio, as I pointed out, the ratio, some things when you divide 7 or 5 by 12, it doesn't work out evenly. You have this repeating decimal that goes on forever. So in Base-12, it's simply 0.7, 0.5, 12, and you can work with that, and you can start to build something that's precise and exact. I spent some time analyzing these words. What's the difference between precise and exact when you're talking in math? And I really wanted to stress that is what we are accessing now. And because of the scale of everything, it doesn't really matter until we get into the very small. And that's where we're now able to access in physics. We have the ability to break things apart and look at the really, really small. And so we can be so precise that little bit of extra not quite working is important to fix. And it gives us the correct ratios. So that's why Base-12 is important. It's going to enable us to access the patterns that make up our universe at a quantum level, and then take it all the way from the very small to the very large, and kind of tie it all together. And this is what we're trying to do with quantum physics and relativity, or the standard model. There's like Einstein's version of gravity, and then there's quantum physics. There's two fields of physics, and the challenge right now is to somehow integrate them. And I think Base-12 mathematics is the key that will start to enable us to put all these jigsaw puzzle pieces together. And so, yeah, it's a big job to convert everything. All of our measurement systems are in Base-10, but it's in the division of the one where where we're going to find the difference, where things start to make sense as to why it seems important and relevant. So up to this point, it's always been about like a money system or a measuring system, and we're sort of counting our ones, and it kind of goes on the one side of the decimal place, but ultimately it's on the other side of the decimal place where we can see, what we'll be able to see the real difference. So that's basically it for this video. I just wanted to share why this is important. It has to do with physics, and you can see in the diagram the relationship of the space and the solid, and that was a lot for me even to I'm going to show you something actually, because I'm going to share something. This whole process for me, a lot of the information that I'm sharing has come to me through dreams that I had, and there was a lot of them, and they're still coming, and they give me lots of hints. And when I was first starting, my initial assumption was to make a continuous line around the circle. That's just the way we've always done it, this idea of a solid line. It's actually quite controversial, this idea of separating all the individual units of the diameter when you put them on the circumference and there's a space between them. And one of the dreams I had, I'm just going to pick this phone up here. All right, so I'm in my backyard and I'm standing in front of this shrub here called a calocarpa. You can see it's got these beautiful purple berries right now. So this is the right time of year where I can share this with you. I had a dream one night, woke up, and it was just an impression that this shrub had something to do with the diagram for 360 degrees. And so when you look at it, you can see, and I'm just going to flip around here, so you can see how you've got the branches, the sticks, and then these little berries at the end. And so if you kind of look at that. All right, so basically that idea of the branches become the lines between the circles when we're making the structure of the diagram for 360 degrees. So I just wanted to share that. It's something kind of unique, and that's one of the first instances where I started to think that there's two qualities to this idea of the circumference of the circle. And so where that leads us to eventually, as I go in the book at the end, I'm talking about toroids, which is basically a donut shape, and that's where we end up in terms of the smallest particle or unit. So currently in physics we have something called string theory, where the theory is that the smallest things that make up our universe are strings, and it's those strings that are vibrating and twisting and turning that generate the fields that build up to the world that we live in. I think right now the consensus is that that's wrong. It hasn't really worked out. There's no actual evidence that shows that that's the right theory. This geometry leads us to a unit that has those two small circles within a larger circle, and that's, again, the geometry of a toroid, or like a donut shape. And I think that is actually the theory, toroidal theory or torus theory, if you want to call it something, where that's the smallest unit, and we kind of end up there by just looking at the circumference of the circle, like really going smaller and smaller. I take you on that journey in the book, and we end up with something that looks like a toroid. So I think that's the structure of the smallest particle in the universe. And from there, we can start to figure out how the fields are generated and build our way back up into the world that we live. So that's a very, superficial, very simplistic version of the theory, but it's a start. And I think it's a worthy direction to explore, given that we don't have anything else right now. And physics, as I said, is in a bit of a crisis. So this theory is supported by the math and the geometry that is in the book. You've seen it there. That's why I think this is important. I think Base-12 is the way to go in terms of solving the mysteries of the universe. So you're a part of that journey now, that you know what's going on, and I'm glad that you're here. And I think I'll just leave it at that for this video. And we're going to keep going with that book, and I'm answering questions. Anything you want to know, or share or talk about, I'm here supporting this idea and promoting it, and we're just going to keep going.